So this is really an extension of what we have seen before. Example 1 says find the volume of the solid formed by revolving the region bounded by f of x is equal to 2 minus x squared and g of x is equal to 1 about the line y is equal to 1. So let me label a couple of things. We have an inverted parabola.
Inverted.
And we have the line y is equal to 1. So you can see that the shaded region is completely flush and touching everything about the axis of rotation. So this is going to be a disk. The difference between this and what we did previously is previously we were revolving it about the x or the y axis. And this, we are revolving about the line y is equal to 1. But it's still a disk in this case. So I have volume equals pi. And again, I have the pi because the base of my disk is a circle. And so it's pi r squared. So I have the integral. Bounds are going to be the intersection point here. So -1 and +1. And then I'm going to do the top minus the bottom to get the radius. Because if I take this region that is shaded, rotate it about the line y is equal to 1, it will form a bunch of disks. And the radius of that disk would be from the top equation to the bottom equation. Okay, so I have 2 minus x squared. And then I'm going to subtract the bottom part. So I've got -1. This gives me r. And then I square it. So I've got pi r squared. And then the height of the cylinder comes from the bounds. So I'm going to write the dx in there. And again, the difference between this one and the last one, on the last one, we were just subtracting 0 because it was the y-axis or the x-axis. Okay, so now take your little calculator, which, as one of my students pointed out, we didn't have when I was learning calculus, right? We had to learn, we had to do integrals on our abacus.
What is that?
Google it when you get your phones back. All right.
Abacus?
Actually, it was a slide rule. My bad. Google that too. Get your calculators. Don't throw it.
Let's go, Zach. Are you gonna do it or just sit there?
The balls, you want to do it?
What are you, what?
Oh my goodness.
Let's go. So no house of different breed.
And
That's not enough time.
somebody help me out here.
Shut up.
0.94.
You might get something like 16 over 15 pi or 1.06 repeating pi, or the decimal was, what was it? No, check that.
Huh?
3.354. Rounded to 3 decimal places. Okay,
So any of those answers?
yes.
That was so easy just now.
Well,
Like, miraculous.
let's look at the next one. And so the next one, it's the same equations. So I have the same shaded region. But this time they asked me to rotate it about the line y is equal to -2. So let me draw that in.
Wait. Why is there 2 lines on each of them?
Because the shaded region is the area enclosed by the inverted parabola and y is equal to 1.
So where's y
So
equals
it's-
-2?
You draw it in at
Okay.
y is equal to -2. Okay, so on this one, we have a formula. It's going to be pi integral from a to b. And then I've got r1 squared minus r2 squared. This one is a washer. And the reason it's a washer, again, the shaded region is not flush up against the axis of rotation. And so we have two regions that we need to define. Let me draw them for you. All right. The first one's R1. It goes from the top curve all the way to the axis of rotation. That's R1. The second one goes from the edge of the shaded region all the way to the axis of rotation. So that's R2. Let me write those down. R1 goes through the shaded region R1 goes through the shaded region to the axis of rotation. So again, looking up here, R1 starts at the top curve, goes through the shaded region all the way down to the axis of rotation. R2 is a rebel droid with secret plans to destroy the Empire. That's a little funny, right? I mean, right? I mean, did anybody write down a rebel droid on the notes? Come on. You had to think about what R2 is. I mean, it's a little. Did you appreciate my joke? Well, thank you. We don't want to stray from our calculus notes. Hold on. Let me.
I'm so confused.
Need to come up with something like 88 or something. R2 is not the rebel droid with the secret plans to destroy
Why
the
don't you just
Empire.
erase that? I just wrote it.
Because it's a joke, Jacob. R2D2, come on. Have we never seen Star Wars?
No.
Ah.
I wanted to.
Okay, hold on. Let me clean up this mess. I did this in my first period, and they're like, it's 7:30 in the morning, coach. That doesn't mean we can't laugh at 7:30 in the morning. Let's have a little fun with our calculus notes. R2 goes from the edge of the shaded region to the axis of rotation. In other words, it is the whole of the washer. Okay, so again, looking up here, I'm taking this shaded region, I'm revolving it about the line y is equal to -2. R1 goes from the top curve all the way to the bottom, axis of rotation, and then I need to subtract off the whole of the washer. So I'm going from the edge of the shaded region all the way to the axis of rotation. All right. So I have pi integral. The bounds have not changed. It's still -1 to 1. I'm going to label top, bottom. So let's do R1. It's the top curve, which is the inverted parabola. So 2 minus x squared. I'll get there. I'm not done yet. Minus the bottom. And the bottom is the axis of rotation. So it's minus a -2. And then that's squared. So that gives me R1. And I'll simplify it in a second. Okay. But I wanted to show you that I have top curve, inverted parabola, 2 minus x squared, minus the bottom curve, which is the line, -2, minus, and now we do R2. R2 goes from the edge, which is y is equal to 1. So I've got 1, positive 1, minus a -2, and then that squared. And all of this should be in brackets with respect to x. You need the dx there. But let me clean this up. So we have pi times the integral from -1 to 1. I've got 2 minus a -2. So that's going to give me 4 minus x squared, and then that's squared. Here I have 1 plus 2, which is 3, and 3 is squared. Okay, so I've got -9 for the second part. Put my brackets in, it's with respect to x, and now we can math 9 it. Although, if it's calculator, you do not have to simplify that. You can just put all of that into your calculator. Just make sure you get all your brackets and squares and all of that correct.
How'd you find R2 again? What'd you do for R2?
Okay, so look, R2 goes from the edge of the shaded region all the way to the axis of rotation. So the top is y is equal to 1, so 1 minus, and then -2. So that gives me 3 squared for R2. I just want to say D2, right? I mean, it just rolls off the tongue, right? So answer to this, I got 136 over 15 pi, or 9.06 pi, 9.06 repeating, or 28.484. Okay. So that's a washer. I'm going to do one more here with respect to y. So let's take a look at that. The region between the parabola y is equal to x squared and the line y is equal to 2x is revolved about the line x is equal to 2 parallel to the y-axis. Find the volume swept out. Okay. Once you get the hang of these, I don't think these are too bad, but it is really important, I think, that you set them up correctly and label them correctly so that you will not get confused. So we are talking about the shaded region between these two curves, between the parabola and the linear function. We are looking at the vertical line, x is equal to 2. It's going to intersect here at 2, 4. And I am rotating this shaded region about the vertical line. X is equal to 2. Therefore, this is a washer. Therefore, it's going to be pi integral from a to b, r1 squared minus r2 squared. So if this is the case, label your R1 and your R2. Since this is parallel to the y-axis, I'm going to be integrating with respect to y. So it's going about this line, x is equal to 2. And if it is with respect to y, that means it's not with the top on the bottom, it is right to left. So I'm going to label it, all right? I'm going to draw R1. R1 goes from the axis of rotation all the way through the shaded region. So that would be the linear function there. And then the whole of the washer goes from the axis of rotation to the parabola. That will be R2. And then I'm going to put a top and a bottom over there so that I don't get those backwards. So here we go. equals pi integral. Careful, the bounds, it's with respect to y, so I need y bounds. So 0 to 4. R1. The top is on the right side. So it's the equation 2, x is equal to 2. So I've got 2 minus R1 goes from the axis of rotation all the way through the shaded region to the linear function, but I've got to write my linear function as x equals because it's with respect to y. So I'm going to solve that real quick, which gives me x equals 1/2 y. So I've got 2 minus 1/2 y. And then don't forget your squared. Minus. And now I'm going to do R2. So I've got the axis of rotation is my top curve. So it's 2 minus the bottom curve, which is the edge of the shaded region, which in this case is the parabola. And again, I've got to write this in terms of x equals. So I have x equals, solving for x, the square root of y. So I've got the square root of y, that's squared, put the brackets with respect to y. Now I can math 9 it.
Let's go look.
So take your little calculator.
So the bounds that you put is like what the.
It has to be y bounds because it's with respect to y. So
But you can plug
the
in.
bottom y bound is 0. Right here, the top y bound is 4. I'm looking at it this way, up and down. Okay, somebody help me out. 2.66 repeating pi, or what's that as a decimal? Thinking
That was so.
8.378. Either one of those.
We done now?
Unfortunately, we are not.
Yeet.
There's a little FRQ.
45
And
minutes?
guess what? It is not calculator, so let's head on into the jungle and put those calculators away.
I can actually do it. Can I do it by myself? I can do it by myself.
How about you let me work through it?
Nah.
And then you should have plenty to do on your own
No,
there.
no.
All right. So this is non-calculator. So they have to give us things that work out. It says, let R be the region in the first quadrant, bounded by the graph of y is equal to 2 square root of x. So as I'm reading, I'm looking at the graph and I'm thinking, okay, that's the lower curve there. The horizontal line, y is equal to 6, that's the top curve, and the y-axis as shown in the figure. Part A says find the area of R. Okay, so this is just like what we did on the first part of this unit. I'm going to draw my little reference rectangle, label it top and bottom. And so we're just finding the area. So there's no pi, there's no squared. We're just going to integrate and do the top minus the bottom. So for A area equals the integral. Just be careful on the bounds. What are the bounds? Since it's
0 to 9.
top minus the bottom,
0 to 9.
and I'm going to integrate with respect to x. My bounds are 0 to 9.
Let's go.
The top equation is 6 minus the bottom equation. I'm going to write this as 2x to the 1/2 and close it and put a dx.
Crank that DX.
And now, unfortunately, I can't use my calculator. I mean, come on, College Board, that is so annoying. It's like what Newhouse had to do back in the day with no calculator,
What's it called?
right?
What's it called?
The abacus or the slide rule. So here we go.
The hibiscus.
Antiderivative of 6.
6x. Oh.
Indeed. All right.
Oh, that one.
On the second one, I'm going to add 1 to the exponent. 1/2 plus 1 gives me 3/2. And then I'm going to divide by that. So I flip and multiply. 2/3 times -2 gives me -4/3. And this is evaluated from 0 to 9. So whenever I plug the 0 in, it's just going to be 0. So I'm not going to worry about that. Although be careful. Like if it's not always 0, if it's a trig function or something else, right? But I am going to plug in the 9. So I'll plug in the 9. I have 6 times 9 minus 4/3 9 raised to the 3/2. And I'm like, come on, seriously, College Board? How are we supposed to do this without a calculator? That's a good question.
No,
Shall we just
you told me that.
stick our proverbial heads in the sand and hope the problem goes away? Shall
No. You square root it and then you multiply by 3. Or do the cube thing.
All right, so look. I raise a power to a power. So 9 raised to the 1/2 raised to the 3rd is the same thing as 9 raised to the 3/2. 9 raised to the 1/2 is the square root of 9, which is 3. 3 cubed, 27. 27 times 4/3, 3 goes into 27 9 times. 9 times 4.
36.
So 6 times 9.
54.
So I have 54 minus 36, and that's, please don't do all that arithmetic and then mess up the
4,
subtraction,
10, 18.
right?
That's what I'm
18. Woo.
Alright.
Oh, wait, I ran out of room.
All right. So here we go, part B.
Right. Do not evaluate.
Again.
Mr. Newhouse.
Set these up.
Don't do it.
Draw and label. Right, but do not evaluate. Thank you very much, College Board. An integral expression that gives the volume of the solid generated when R is rotated about the horizontal line, Y is equal to 7. Okay. Let me erase that real quick. Drawing the line, Y is equal to 7. So I am taking the shaded region and I'm rotating it about the line Y is equal to 7. The shaded region is not flush against the axis of rotation, and the axis of rotation is not the x-axis. So this is a problem like what we just learned. So I'm going to draw R1 and R2 and label them. R1 goes from the axis of rotation all the way through the shaded region. R2 goes from the axis of rotation to the edge of the shaded region, and I'm going to label those two things. So
Is it a
I'm
wash?
also going to label top and bottom.
Oh.
So here we go, part B. Volume is going to be, I need a pi, because it forms a washer, times the integral. My bounds, this is with respect to x, so my bounds have not changed. Okay, and so look up here, R1, top equation is 7. Bottom equation is 2 minus the square root of x. So I have 7 minus 2 square root of x, and then I square that, and that gives me R1.
That.
Minus,
Oh.
now I've got R2. Top equation is 7. bottom equation is going to be y is equal to 6. So R2 is just going to be 7 minus 6 squared, or you could write it as 1. Simplifying on the fly. I'm going to put my brackets in and put in my dx.
I have to put brackets in.
And I am done because they asked me to just evaluate. Excuse me, they asked me to set it up. Do not evaluate. Okay, so we had an area problem. We had a washer about another access problem. And the last one,
I know how to do it.
region R is the base of a solid. For each y, where y is between 0 and 6, the cross section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base in region R. Right, but do not evaluate, thank you, College Board, an integral expression that gives the volume of the solid. Okay, so again, I think it is very helpful to label and draw a picture. So let me erase all of this. So the base, they said, was perpendicular to the y-axis. And the cross section is a rectangle. So there is my representative rectangle. Perpendicular to the y-axis. And you will recall the first thing that you should do when you are writing, when you are working cross-section problems is a formula for the area of the cross-section. This is a rectangle. And so the area of a rectangle is base times the height, or length times width. Let's say base times height. Then you will also notice, as you are reading the problem, it says that the height is 3 times the length of its base. So I'm going to replace the height in this
3B.
with 3b, which means my generalized formula for the area of the rectangle is 3b squared. Okay, and so now I need to just find an expression for the base. Okay, so part C here, we have volume equals pi or no pi? Why no pi?
It's a rectangle.
It's a rectangle. It's not a disc or a washer.
I'm so hungry.
Yes. 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 Can you wait like 5 minutes?
I think it's for me. Is it for me?
Rachel. Don't vibrate your laptop. But wait till we're done. We're almost done.
We're almost done.
Okay. So there is no pi because the cross section is a rectangle. You only have pi with disc and washers, or if the cross section were a circle or semicircle. Also, since the base is perpendicular to the y-axis, I'm going to be integrating with respect to y. Therefore, the bounds are with respect to, I need y bounds. So 0 to 6. And I'm going to be integrating my expression for the area of the cross section, which is 3b squared. So I need to find b. You can if you want. All right, so look at my picture. The base goes from this curve to this curve. And since I'm integrating with respect to y, I'm going to label it top and bottom. The bottom doesn't matter because it's the y-axis, therefore it's 0. The top curve is this. However, since I'm integrating with respect to y, I need to have y's in my integrand. So I'm going to solve this. So 1/2 y equals the square root of x. Don't make a careless mistake. Square both sides. Don't take the square root. So I've got x equals 1/2. Excuse me, 1/4 y squared.
Let's go.
So this 1/4 y squared minus 0 gives me my base. So I'm going to take this value, substitute it in for b, and it is all over.
You did too
Right.
much though.
So I have the integral from 0 to 6 of 3. My base is 1/4 y squared. And then that base is squared. And this is with respect to y. And now, since I have so much time left on my hands on this FRQ, I mean, I might as well simplify it for the AP grader, right? So integral from 0 to 6, squaring that 1/4 squared is 1/16 times 3. So I got 3 over 16 and y squared squared is y to the 4th dy. Show me what you got, College Board.
Little sips. All right, can you grab my quiz?
No, I'm not done.